Hi, let us continue our lecture and consider in more details the decision trees. What is the decision tree? Basically, it's a structured way of selecting the most optimal solution when you have several competing alternatives. I have prepared some definitions and also an example on decision tree. Later on, I'm going to demonstrate in Excel how to construct decision trees. And I will assign assignment for Learning Plan 1 seminar. Okay, let's go then. So first I would like to present a definition, expected monetary value. Basically, what is the expected monetary value? It's if you think about the discrete distribution, so we have a probability associated with a certain random variable, and if for example we have two alternatives, then it means that random variable can take two values. In this case we have two alternatives, so it means there are two possibilities for that random variable to happen, either for example either favorable market or non-favorable market. So basically it's a long-term expected value of that particular decision tree. Okay, in the example, once we consider example, it will be much clearer. So what is the decision node? Decision node, I took the definition from the text: node from which one or of several alternatives may be chosen. So basically, in this example, there are two alternative decisions to be made. Let us imagine it's a medical device company, and we develop a product for marketing. We have two competitive designs, design 1 and design 2. So in this case, two decisions, there's a decision to be made, and which will be a selection between design 1 and design 2. So design 1 and design 2, they culminate in decision node. Then there's another type of nodes which are called state of nature node, and basically out of which one state of nature will occur. So either for example, in this situation we consider whether market for that particular medical device will be favorable or not, and indeed it can be either favorable or non-favorable. It can't be both. So that's why we say mutually exclusive state of nature. And certainly there's a certain payoff associated with the marketing of the device, and payoff depends also on the whether market is favorable or not favorable. So we assign the probabilities. Again, it's an educated guess, or it's an outcome of the more extensive research. So certainly the more input we put into the determining the probabilities of favorable and non-favorable market, the more exact our decision will be. Okay, and then how we calculate calculate expected monetary values. It's the same thing as in chapter 2 the examples are calculating the expected value of certain distribution. So it's a weighted average of the two outcomes. So payoff for the favorable market for design 1 is $10 million, and for non-favorable market is $500,000. So the respective probabilities of favorable and non-favorable are 0.7 and 0.3. For design 2 alternative, the favorable market is gonna bring $10,500,000, and non-favorable market is estimated to bring $200,000. The probability of favorable and non-favorable markets are still the same, 0.7 and 0.3. So we calculate expected monetary value 1 for decision for the node 1. So it's 0.7 times 10 million plus 0.3 times 500,000. It's $7,150,000. So I'm going to put over here $7,150,000. For EMV2, the numbers comes to $7,410,000. Okay, so certainly for decision node we select the most favorable monetary value for us, and in this case is $7,410,000. So the best design is selected. In this case is design 2. So it's pretty simple example. The real life problems could be more complicated, but the principle stays the same. And I'm going to consider this example in Excel. Also for homework, we're gonna repeat the same exercise with one more design added as an alternative. It's pretty simple. It will give you some experience, and it will not take much time. Okay, see you in the next part.